Hey guys, welcome back. We are going to delve into Chapter 3. Hope you guys are ready. Alright, Chapter 3 is all about exploring more about linear functions. So we're going to start off with a little review, which is about rate of change and slope. I know we already talked about this year, but it's always good to review. So our Common Core State Standard is FLE1, probably standing for functions, and then linear equations, maybe, I don't know, something like that. Anyway, it says recognize situations in which one quantity changes at a constant rate relative to another. So rate of change and slope is what we're going to look at. All right. Okay, so rate of change shows the relationship between two changing quantities, not qualities. Anyway, so rate of change is the change in the dependent variable over the change in the independent variable. Okay, now dependent and independent, you have to make sure you know the difference between those two things. Dependent is the variable that changes depending on the other variable. Okay, the dependent variable is going to be our y. The independent is going to be our x. Okay, so let's look at this table down here. This says, so basically change in y over change in x. So the table shows the distance a marching band marches over time. Is the rate of change in distance with respect to time constant? Okay, so we have to look at the rate of change. So basically this goes up by 1 each time. This goes up by 260. There's not a lot of room over here. Okay, now remember, when you're looking to see if it's constant, you don't just look at the numbers and say, okay, this goes up by 1 each time, this goes up by 260. You have to look at the ratio, the rate. So each of these is going to be 260 feet over 1 second, because that's how much it's changing. And that's the same for all of these, because they're all the same. So this is obviously a constant rate of change, and it's going to be 260 feet per second. Okay, so it is constant, yes. Time is our x. Time is almost always the independent, so it's almost always the x. This is almost always, distance is the y. And this is, what does this represent? Okay, so what this means is that for each additional minute marched, the band gains a distance of 260 feet. Okay, or they're marching at a pace of 260 feet per minute, not per second. That would be super fast. Per minute. That's why it's important to get your units correct. All right. And onward we march. Just kidding. Okay. Determine whether the rate of change is constant. If it is, explain what it means. Okay, so go ahead, you can try this. You can pause it in 3, 2, 1. Alright, so these could be kind of tricky if you were confused about this. Let's look at this. The one is talking about a turtle walking. So if you look at the distance here, the minutes go up by 1 each time. But then our miles, or meters, it goes up 6, then 3, then 6. So if we find our rate of change, what we do is we do 6 divided by 1, which is 6. Then we do 3 divided by 1, which is 3. So already we can see that this is not constant because that second minute he just walks a little bit slower, about half as slow actually. So that one's not constant. However, we look at this airplane descent here. Now when you find the changes, we have negative 1,000, then negative 1,500, then negative 3,500. So I don't want you to see those numbers and say, oh, those are different, so it's not constant. Because look at what's happening to the minutes over here. The minutes aren't going up by the same amount either. It's going up by 2, then 3, then 7. So remember, you have to do your rate of change here. So you got to take negative 1,000 divided by 2, which gives us negative 500. Negative 1,500 divided by 3, which again gives us negative 500. Negative 3,500 divided by 7, which again is negative 500. So even though these numbers aren't the same, when you find the rate, or the ratio, they all end up negative 500, so it is a constant rate of change. Constant rate of change. Hallelujah. This means it's linear. And what that means is our constant rate of change will be negative 500 feet per minute, which basically means the airplane is descending at a rate of 500 feet per minute. It's losing 500 feet in elevation per minute. All right, so when you have this plotted on a graph like this, you can just find the change in the rate of change by looking at the rise over the run, or the slope. So our slope here is the vertical change over the horizontal change. So this is from the marching band problem. So notice they plotted each of these. So at 1 it was at 260, so they plotted that point there. And then 2 it was at 520, I think. So there's that point, and then 780, and so on. So if you want to find the rate of change, or the slope, you just got to do rise over run. So pick any 2 points. So on here they did up 260 and over 1. So the rise over run would be rise 260, run 1. 260 divided by 1 is just 260. And remember, because this line is going up from left to right, this should be a positive slope. So make sure this is a positive 260. Alright. So what is the slope of this line? So it's kind of giving you some hints here with these little air bubbles. But our rise over run here, again, this should be positive. So I'm going to use m for slope. M is going to be rise over run. So here we're rising 2 units up, and then right 3 units. So 2 over 3 should be our slope, and that doesn't simplify. This one we are going down 4. So rise is 4, and then run is 5. And notice this line is going down. So if I read this from left to right, this should be a negative, so negative slope. That's why it says going down 4 units, so I can put the negative on the 4. Or if you're starting here, you can go up 4 and then back 5, because if I'm going back 5, that's also negative. So just make sure the sign matches the direction the slope's going. So if the line's going up like this, it should end up being positive. If the line's going down like this one, you should have a negative in front. Okay. So then you don't really get confused about where to put the negative. Just look at the direction of the line. Then you just have to think about the rise and the run. You don't have to think about negatives and whatnot. Alrighty, go ahead and try this one, A and B. You got it. Ready? Break. 3, 2, 1, pause. Welcome back. Here we go. So this one is a positive slope. It should be positive 2/5 up 2 over 5. This one is a negative slope because it's going down. It should be 2/6, which simplifies to 1/3. Always simplify your fractions. So we get negative 1/3 there. Here we go. Halfway there. All right. So we have our slope formula. I know we've talked about this before. But if we have 2 points, so in here they've used x1, y1 for A, x2, y2 for B. If you want to find the slope, you just have to find the distances, basically. So your rise is going to be the y2 minus y1. Your run is going to be x2 minus x1. So our slope formula, rise over run, we get y2 minus y1 over x2 minus x1. Okay, and again, it doesn't matter which point you choose for x1 and y1, as long as you keep them on top of each other. So the x2 and the y2 go together, x1 and y1 go together. Okay, so that's our slope formula. Make sure you know that. Slope formula, it's an important one to remember. So subtract the y's on top, subtract the x's on bottom. So now if we use that for this, I'm going to call this my x1, y1, x2, y2. And then to find my slope, I just subtract. So I'm going to do y2 minus y1 over x2 minus x1. Here we go. Y2 is going to be negative 2, minus y1 is 0, over x2, which is 3, minus negative 1. This just gives us negative. Don't know if you got this, but this one was m equals negative 1/2. Sorry it paused. Don't know where it paused. I know this happens a lot. My bad. Anyway, use the slope formula to try this one. So you got these 2 points, 1, 3, and 1, or 4, negative 1. So go ahead, 3, 2, 1, pause. Alright, so we should have got negative 4/3 here, because I did negative 1 minus 3, and then 4 minus 1, negative 4/3. Hopefully you got that. Alright, okay, so we haven't really looked at these this year, so let's look at slopes of horizontal and vertical lines. So, if I do this using the slope formula, I've got my 2 points here, it's identified. I'm going to subtract my y's, so 2 minus 2, here's that 2 minus that 2, over 2 minus negative 3. Because this 2 and this negative 3. Minus negative 3 just turns into a plus. Well, 2 minus 2 is 0, over 2 plus 3 is 5. 0 divided by 5 is 0. Okay, so when you think about this, this is a horizontal line. A horizontal line has no slope. Okay, it's just flat. So the slope is 0. Okay, it's not positive, it's not negative, it's a flat line, so it's a 0 slope. So a horizontal line always has a 0 slope. Now, if you think about this vertical line here, that's very steep. It's infinitely steep. It's not flat, so it's not going to be 0. So when we do this one, let's use our formula again. So I'm going to subtract my y's, negative 2 minus 1 over subtract my x's, negative 2 minus negative 2. So this gives us negative 3 on top. That turns into a plus over 0. Negative 3 divided by 0. This is not 0, not equal to 0. So remember, you can't split 3 things into 0 groups. It doesn't work. Okay, so this is undefined because we cannot divide by 0. So whenever you have a vertical line, the slope is undefined. A horizontal line, the slope is 0. Okay, because really, if it's a vertical line, if you think about like hiking a mountain, you can't really hike something that's purely vertical, unless you're like rock climbing or something, I guess. But there's no slope there. I mean, there is slope. It's just an infinite amount of slope, so it's undefined. Okay, if it's a flat, then the slope is 0. It's a nice, easy little hike there. So horizontal, slope is 0. Vertical, undefined. Okay, so go ahead. There's 4 problems here. Go ahead and try them. Pause this in 3, 2, 1. Alright, so I've written these out. The first one ends up being 5 over 0, which again is undefined, which tells us that this is a vertical line. You could have also plotted this. So like if I plot these 2 points, 4, 2 should be here, 4, negative 3 is down here, down here. Anyway, they make a vertical line. So that's an undefined slope. This one over here, you get a slope of 0, so that's going to be a horizontal line. And then same thing with 7 and 8, you can just look at these, because it's a vertical line here, undefined slope, because this is horizontal, slope is 0. Easy peasy. Alright, in summary, we have the slopes of lines. This summarizes what we have learned about slope. So if it's positive, you should be going up. We always read left to right. So when you're reading left to right and it goes up, it's a positive slope. If it's going down, like so, it is a negative slope. A vertical line is an undefined slope. Horizontal line is a slope of 0. Okay, so those are the 4 types of slopes you'll see with these linear functions. Actually, this one's not a function because it's a vertical line, but those are the types of slopes you'll see. Alright, that's all I have for today. I will see y'all later. Alright, thank you. Next.